Compressible flow, tutorial number 8. In one-dimensional isentropic flow, show that the temperature and pressure ratio between 2 points is given as this equation and this equation, where K is the specific heat ratio of the flowing gas and M is the Mach number. Given for isentropic flow, Cp T plus V squared over 2 is a constant value, and P by the power of K minus 1 over K over temperature also a constant, where Cp is specific heat at constant pressure and V is a local velocity. From the question, we know that Cpt plus V squared over 2 is a constant. So that if we have 2 points, it can be written as Cpt1 plus V1 squared over 2 equal Cpt2 plus V2 squared over 2. Then this equation can be simplified into these terms, and finally we could say that it can be written in terms of ratio of T2 over T1, and we get this term. We state this equation as equation number 1. From previous lesson, we know that R equal Cp minus Cv. Cv is 1 over K minus 1 R, and Cp is equal to K over K minus 1 R. And from this equation, we could say that we could simplify Cp as Kr over K minus 1. Then we state this one as equation number 2. Then we substitute the value of Cp in equation number 1 with Cp equal Kr over K minus 1. And we have this equation. And then we could simplify the right-hand side term into this one, K minus 1 V1 squared over 2Kr T1. And then we name this equation as equation number 3. We also know that Mach number is velocity over speed of sound, and it can be written as V over C or V over third KRT. And then we could say that KRT can be written as V squared over Mach squared. We assume this equation as equation number 4. Then we substitute KRT in equation number 3 here with this term. Then we could have K minus 1 V1 squared over 2 M1 squared over V1 squared. Then we could simplify this one as 1 over 2 K minus 1 M1 squared. We state this equation as equation number 5. And then previously we have term of V1 squared over 2 Cpt1, and now we could say that terms of V2 squared over 2 Cpt2 also can be written as 1 over 2 K minus 1 M2 squared, and we state this one as equation number 6. After this, we substitute equation number 5 and 6 into equation number 1. So this is equation number 1. We have V1 squared over 2 Cpt1 and V2 squared over 2 Cpt2. We substitute these two equations with the equation number 5 and equation number 6. And finally, we could have the ratio of T2 over T1 is equal 1 plus 1 over 2 K minus 1 M1 squared over 1 plus 1 over 2 K minus 1 M2 squared. And then we could prove that this is the isentropic flow equation for the ratio of temperature. We state this equation as equation number 7. From question, it is given that P by the power of k minus 1 over k over t is a constant, and for between 2 points, we could write like this. And then we could rearrange this term into t2 over t1 equal p2 over p1 by the power of k minus 1 over k. And we state this equation as equation number 8. Then we substitute equation 8 into equation number 7. So we have P2 over P1 by the power of k minus 1 over k, and then we have 1 over 2 k minus 1 m1 square over 1 plus 1 over 2 k minus 1 m2 square here, and then we rearrange the power here to the right side. We could say that the isentropic flow for ratio of pressure can be written as this one. So this is the method to prove the isentropic flow equation for temperature ratio and pressure ratio. I hope you could remember this.